the combination of day 6 and 7. Here it's a starter. One of the questions is 5x plus 1 over x plus 4 is equal to 4, and how would you solve that? And this is quite easy, right? You multiply both sides by x plus 4 in brackets, and here the x plus 4 would simplify, and here you have 4 times x plus 4 on the right side, and then distribute and simplify, and you get x equals 15. Well, that's easy. How would you solve this inequality? Well, it works almost exactly like the equations, except if you have to multiply both sides by a negative number, then the direction changes. So here we have, I subtracted x from both sides, and that was okay, nothing happened, right? And then I subtracted 2 from both sides, and nothing happened. It's exactly the same, and divided both sides by 2, and nothing happened. But if you were to take this question and solve it differently, right? So here, if you had 3x plus 2 is greater than x minus 5. If you were to maybe subtract both sides by 3x, then you would get 2 is greater than negative 2x minus 5. Add 5 to both sides, 7 is greater than negative 2x. And here I want to divide both sides by negative 2. So x and something with negative 7 over 2. Now if I put this without changing direction, that means x is less than negative 7 over 2. But that's not true, right? X has to be greater than negative 7 over 2. So when you multiply or divide by a negative number, you switch directions. Okay? You learned that last year. Day 6 was solving inequalities graphically, and here's a very general conceptual example. So we want to know when f of x is greater than g of x. In the graph, that'll show as one f of x being above g of x vertically, right? When does that happen? Well, the important thing to find is when they are in fact equal to each other. And the 3 places where they meet are here, here, and here. So you can think about, all right, to the left of this point, is f of x above g of x? Yes. So anything from this side here all the way to negative 1, f of x is above g of x, right? So that's good. From negative 1 to 1.5, f of x is below g of x, so that's not going to work. From 1.5 to 4, f of x is again above g of x, so that's good. So you can write your solution. It's going to be an interval from negative infinity to negative 1. And union 1.5 to 4. The endpoints are not included because we want to know when f is greater than g. If it's greater than or equal to, then these endpoints, except for the infinity one, would be included. Here, we want to solve this with the GEC. It says 2 minus 3x is less than or equal to negative 6x squared minus 20x, and that left side is a straight line, the right side is a quadratic. I graph these, that one in y1, here in y2, and if you do that in your graphing calculator, this is what you get. Okay, so without actually finding what these values are, it's going to be from here to wherever they intersect here, and you want to know when this quadratic is above, and that has to be between those 2 points because that's when this happened, right? So all you have to do is find the intersection here and here, and then write it that way. So let's go. Here, so I'm going to find the intersection. Yeah, that's why I couldn't remember what these were. It's negative 0.123 and 2.369. And the left one, trace 5, enter, is negative 2.71 and 10.1. So the x values are negative 2.71 and negative 0.123. So when does this happen? it's between those two numbers, negative 2.71 less than or equal to x, which is less than or equal to negative 0.123. Okay, so now we're not going to use our graphing calculators, and we're going to solve this inequalities. Earlier, it was example was quite easy, so we're going to do something with the algebraic expression inside the absolute value sign. Of course, you can graph it if you know what this looks like, but there are other ways. There are analytical way. So first thing, I'm going to add or subtract 2 from both sides. Okay, and then I'm going to multiply both sides by negative 1. And in an attempt to get the absolute value symbol and what's inside on one side of the inequality. So the sign changes size, and so we have absolute value of 4x minus 5 is less than 9. Now, you might have learned some tricks on how to do this fast, but I'm going to do this maybe the long way. Okay, so you have two cases. 4x minus 5 could be positive. In that case, the absolute value sign does absolutely nothing, and that's what you get, right? So you add 5 to both sides and divide both sides by 4. So x is less than 7 over 2. So this is one possible solution. And then here, 4x minus 5 could be negative. In that case, if you add the if you multiply that by negative 1, then this is true. Okay, so I will multiply negative 4, multiply the negative 1 plus 5, negative 4x, subtract 5 from both sides, and then x is greater than negative 1. You have to flip the sign because you're dividing by negative 4. And there you go. So x is greater than negative 1, but less than 7 over 2. So you can actually combine them. That way. Now we're in day 7. We're solving inequalities analytically. The only problem with a problem like this is that we don't know x plus 1 is positive or negative, right? We already learned that we can't multiply by a negative number without switching the sign. So sometimes it's positive, it could be positive, it could be negative, so we don't know. So how do we deal with something like that? Well, I want to multiply by a positive value. That way I don't have to worry about switching signs or anything. So you multiply both sides by x plus 1 squared. Okay? No matter what x plus 1 is, whether positive or negative, when you square it, you're going to get a positive number, right? So now one of these will cancel out. So 3 times x plus 1, and then 2 times, we'll distribute this out, x squared plus 2x plus 1. And then 3x plus 1 is, 3x plus 3 is less than or equal to 2x squared plus 4x plus 2. And then I'm going to subtract 3x plus 3 from both sides. So 0 is less than or equal to 2x squared plus x minus 1. And you would get 2x x plus 1 minus 1. That way you get, yeah. Now, we got to here. We know when is it equal to 0. So 2x minus 1 times x plus 1 is going to be when x is 1/2 and negative 1. So you make a little nice number line here. And it's equal to 0 when x is negative 1 and 1/2. So it's either going to be outside here or inside here. And the little trick here that you want to remember is this a value tells you how the parabola opens. So a value is positive, the parabola is going to open up. So your parabola is like that. Okay, so you want to know when this is greater than 0, well, that's going to be here and not here. Okay. Alternatively, if you forget, you can substitute a number in each of those intervals. So anything to the left of -1, imagine -5, for instance. -5 times 2 is -10, minus 11, minus 1 is -11, -5 plus 1 is -4. -11 times -4 is going to be a positive number. Anything between -1 and 1/2. 0, for instance. 0 minus 1 is -1, and 0 plus 1 is +1. When you multiply those two, you get a negative number. Anything greater than 1/2, so 10 maybe, this is going to be +19 times 11. I don't care what the value is, I know it's positive. So you get the same result as drawing this quadratic here. At the end, the answer, when this is true, is for x values to the left of or equal to -1, or to the right of or equal to 1/2. So you can say x is less than or equal to -1, or x is greater than or equal to 1/2. Okay, let's do one more question. The same idea here. I cannot multiply both sides by x minus 1, so I'm going to do x minus 1. I'm going to multiply both sides by x minus 1 squared. So x minus 1 squared, x minus 1 squared. Then we get x minus 1 times 2x minus 4 is less than, I'll just go ahead and distribute this, x squared minus 2x plus 1, 2x squared minus 2 minus 4 is minus 6x plus 4. I'm going to move everything to the left. That way my a value is going to be positive. It doesn't really matter if that's how you like it or not. And then minus 4x, and then plus 3, 0. And that's going to be x minus 3. X minus 1 is less than 0. So when is it equal to 0? Even if it says less than, you are still looking for when it's equal to 0. So you can put that on your number line. It's going to be either 1 or 3. You know those values are not going to be included because that's when it's equal to 0. But here, a value is 1. So my quadratic is going to look like that. Right? So when is it less than 0? Well, that's right here. So 1, between 1 and 3, but not including 1 and 3. That is going to be the solution for this inequality.